Hello everyone, and welcome to this episode dedicated to the regeneration of the biosphere. You are in the second part of the course dedicated to the solution space, a course dedicated to pathways for a sustainable world. So if you haven't seen the first part dedicated to the problem space, I encourage you to do so, because we will spend very little time on it now, focusing instead on how we structure the solutions to address it. And without further ado, I will give a quick and brief recap. As you are probably aware, the current state of the biosphere is very concerning, as species are disappearing at a rate 10 to 100 times faster than normal. So we are undoubtedly facing a mass extinction of living organisms. According to Rockstrom, this is the most concerning planetary boundary. The main causes of the disappearance of these species are listed here. This was the subject of a 2016 paper that was thoroughly researched and meticulously charted by the organization Our World in Data. So what we can see right away is that climate change is here, but it is a relatively minor cause for now, as we can observe. Indeed, it is currently a minor cause at this moment. Contrary to what many believe, the primary cause of species and biodiversity loss is human activity. Human actions such as overexploitation from deforestation, hunting or fishing, and especially agriculture, which is the largest factor both directly and indirectly due to pollution, as well as the development of cities, transportation systems and energy production methods, drive this loss. And the landscape modification that it significantly induces. All of this ultimately contributes to the disappearance of species. So we have a rather complicated and intricate set of causes that we need to carefully consider. The total should be 8,700 species, 8,688 to be precise. And it's much more than that, simply because very often it's a combination of factors at work in the disappearance of species. And we will have the opportunity to come back to this. But before going any further, I would like to take 2 or 3 examples to show you that even though the situation is very concerning, it is not hopeless, far from it, because ecosystems are very resilient and can return to a functional state very quickly. I chose this example because personally I find it very illustrative. Here you have the Amazon that we know or think we know, and then the title, The Domestication of the Amazon Before the European Conquest, starts to catch our attention. And then, when we start to look a little more closely at what is written there, we learn things. In red and orange, you have areas that have been historically established as designated cultivation zones a few hundred years ago for agricultural purposes.
And then in the regions, all the little like dots, the place we planted.
Today, what we seem to see is a virgin forest. Primary, whereas in a large part, based on this analysis, we can see that it is not primary and that it is secondary. Other papers have demonstrated the same for forests in various regions, showing that most forests in Latin America are actually secondary forests due to cycles of cultivation and destruction, followed by regrowth into a wild state over time. So there is a recent paper that shows a bit of the potential and the speed at which this happens. They studied 77 sites undergoing various restoration projects across different regions, including much of Latin America and Africa. And across the 77 sites, they observe a complex and functional forest ecosystem rebirth in less than 2 decades. They looked at 8 characteristics of forests: the state of the soil, biodiversity, the amount of biomass, etc. And in terms of all these various characteristics, in approximately 20 years, they are able to recover about 80% of the characteristics of what is found in a mature forest. So this is good news because indeed we can return to a functional state very quickly. Now, this is not limited to terrestrial environments. This is also the case in the marine environment. I found this example particularly striking. It is from Duarte's paper mentioned in the section dedicated to problems and serves as a clear example of the system's resilience. What you see is corals, a great diversity of corals, which come from the Marshall Islands, which from 1946 to 1958 were bombarded with nuclear bombs, the equivalent of 76 megatons in TNT equivalent, and they had calculated that the surface water temperature could even reach at times over 55,000 degrees. So it's safe to say that everything was roasted. Despite these extreme and harsh conditions, approximately 50, 60 years later, after such a long period, we find fully functional and thriving ecosystems.
This is a comprehensive paper.
That's what we saw in the episode dedicated to biodiversity in the problem space. It was Duarte's paper that said it was possible to rebuild marine life in a few decades if we did it right, because indeed there are, as I have already mentioned, a number of species populations have rebounded, whether it be humpback whales, elephant seals, Baltic sea cormorants, and other species, etc. It's possible, and what they say in this paper is that a more in-depth and comprehensive study of the various different marine ecosystems that have been restored shows a very rapid ability of these ecosystems to recover very quickly and efficiently, whether it's mangroves or seagrass beds. The abundance, structure, and overall function of marine life could significantly recover by 2050 if the primary and most significant pressures are effectively mitigated. There are two main principles. We need to reduce the pressure we exert on ecosystems in a sustainable manner and give them time to recover. We can do it in a variety of different ways. The two simplest approaches are conservation and protection of places and restoration when it is really too degraded. We have roughly the same result in mind for the terrestrial environment, where this research paper shows that approximately 2/3 of future biodiversity losses can potentially be avoided, and it is possible to reverse the trend within 20 to 30 years. To do this, we need to both accelerate the protection of ecosystems and increase protected areas to cover 40% of the land, as this paper recommends, by covering important sites for biodiversity with improved management. We need to generalize the principles of space management in various ways. There are many places where the land and ecosystems are not managed effectively. And then, in addition to extending protection, we also need to furthermore restore 8% of terrestrial areas by 2050. So approximately 8%, that's about 12 million square kilometers. That's 1.2 gigahectares, which means 1.2 billion hectares. And we will see that these figures, although extremely important, are consistent with what is happening today from a political standpoint. There is an entire section of the paper dedicated to the important transformation of agri-food systems, and I'm not discussing it in this one. We will talk about it in the video dedicated to the transformation of food, but it is obviously and clearly a combination of our means of production and consumption as humans, along with protection, safeguarding, and restoration, that will ensure the return of a functional and flourishing biodiversity. So we are going to start the section on protection and conservation, the protection of species, the conservation of spaces and habitats, with some good news first, because not all species are indeed disappearing at a rapid pace. There are also some that we manage to protect and that manage to come back to life, or almost. So the two examples among mammals and birds which are part of the icons are the giant panda, which in China in the 1980s, there were only about 1,000 individuals left. So it was critically endangered. And then, through a series of habitat protection measures and interconnection, as we will see, we were able to restore the population levels, which have almost doubled. Today, the species has been downgraded and is no longer considered critically endangered. It is considered vulnerable because it hovers around the threshold of 2,000 individuals. The California condor, the situation was much worse. It was extinct in the wild, with only a few dozen individuals left, all of them in zoos. In 1987, the American state decided to capture all those they could find in the wild to create a captive population with which they started a program for both breeding and reintroduction. Today, it is not only back in the wild thriving and flourishing, but it is also colonizing various and different states. It can be found in Utah, Arizona, and California, two examples among many others. From a numerical and quantitative point of view, it has been estimated that approximately about 50 various different species of birds and mammals have been protected since the 1990s and would have probably disappeared if it weren't for these protection systems. Everything is in the title. The extinction rate in the past 20 years was at least 3 to 4 times faster without conservation efforts. That means when we provide the necessary resources and can specialize and focus our attention on certain species, by providing additional support and resources and focusing our dedicated efforts on specific species, we can protect them, at least some of them. As you may have noticed, for the past 2 slides, I have only been talking about vertebrates. This is actually what the IUCN Red List was actually focusing on. It's a start, that's where it comes from. And indeed, most of the protection measures and scientific papers on the issue are focused on these taxa, on these groups of species. That doesn't mean there aren't other ways for plants, fungi, and bacteria, but the further we move away from vertebrates, the less knowledge we have on the subject. But what it says beyond a particular species is that it is very important to protect the habitat in which this species lives. That's how, by the way, gradually, as we have seen with the giant panda, we can indeed ensure the protection of the most representative species. And so there is a particular focus on the number of protected areas, which we call protected areas, whether they are terrestrial protected areas or marine protected areas. And there is now a database which is managed by UNEP called Protected Planet. And Protected Planet is the comprehensive and detailed global database of all protected areas that keeps an updated record of everything declared by governments. So it's quite interesting to explore. So, as of the current date, approximately 16% of the Earth's total surface area has been officially declared and recognized as protected. I will definitely come back to it. Nearly 8% of the oceans are declared protected. And then these rates are higher if we add protected areas and other types of areas, but I won't go into that detail indeed. So this is to give a sense of scale. So visually, what does it look like? Here's the planet. So we have areas of different colors. So let's start with the terrestrial. It's the simplest. In green, we see areas protected in 2010. The areas added since 2010 are shown in red. What do we observe? Almost no new protected areas, except for a few small spots here and there in various regions and locations. We will see it better in the next slide. For marine areas, there is also a color code. In light blue, what was protected in 2010, and then in darker colors, we will see what has been protected more recently. What we observe is that the dynamic is essentially completely and utterly different, but so fundamentally the lands, so this is 2 years, it was published essentially 2 years before what I showed you from Protected Planet, so the figures are essentially lower. We get rates which have changed little for land, which have been multiplied by 2.5 for marine areas. There are a lot of purples. There are a lot of areas that have been recently protected in the ocean. What I highlighted in red, and we will come back to it at the end of this episode, are the targets that the international community set for itself in 2010, which they were supposed to achieve by 2020, known as the Aichi targets. What we can see is in both cases it wasn't enough. Whether on land or in the marine environment, these goals were not achieved. That's the glass half empty. The glass half full is it has increased greatly, especially in the marine environment. One important point is that marine protected areas have significantly increased, but because an area is labeled as a marine protected area doesn't mean it is protected. So there's a subtlety here, which is that some areas are more protected than others. And there are areas where, for example, fishing boats can still continue to go, etc. So we have It's vital to differentiate between declared marine protected areas and truly protected areas. In the paper by Sala Lubchenko, the calculation is closer to 2.7%. The IUCN has started making a list of protected sites, and for now it is currently mainly terrestrial, but it primarily covers areas that are terrestrial zones of extremely high protection or conservation value. So we have, if you will, two types of indicators. There is the total number, the total percentage of protected areas, and then the total percentage of the surface that is under the regime of protected areas. And then there is the quality of this protection, which is currently being characterized. So remember that it's a question of quantity, but it's also a question of quality, and we will come back to this at the end. One of the reasons why it is so very important to have large protected areas is because one of the most crucial factors in species disappearance is what we call habitat fragmentation. This is represented here in a very schematic way. Imagine a habitat such as a forest. Then this forest is split in two due to a highway, a city, or the creation of fields. We end up with two half forests, which might seem the same, but actually they're not. Because there are many various factors at play. There are different species that need large spaces to be able to thrive in different environments. You don't necessarily have the same distribution of individuals after fragmentation. And so the smaller the fragment you're in, the less the population will be able to ensure genetic diversity, to maintain the species and so on. The more we cut and fragment, the fewer species we will have, increasing the risk of species endangerment. And this is very well illustrated in this graph, a paper that came out last year, and shows that, in fact, most vertebrates, so we are talking about the same ones again, it's most vertebrates that are close to extinction, so it's the 8,000 or so that we saw earlier on our World in Data, count less than 250 individuals and are dispersed in several small populations.
How do you read this? Here you have the mammals, birds, reptiles, amphibians, and the vertebrate, and that tells you the size of the populations.
Those that are between 750 and 1,000 individuals are populations that are in orange, in red between 250 and 500, in blue and in purple between 1 and 250. So the majority, regardless of the group, the majority of communities of organisms are indeed very small. So habitat fragmentation is really something that, in fact, matters a lot. And that's why the new space management techniques are moving towards very integrative systems. So an example that I find really, really interesting is the Y2Y. The first Y is for Yukon and the second Y is for Yellowstone. So Yellowstone to Yukon is still a very, very large area, as you can see here. The region that is concerned with conservation is the one outlined in orange. It is a gigantic space that went from 8% protection to 18% between 1993 and 2008. So we see here at the beginning there were initially small nuclei that were light green in color. These are indeed the original national parks that are both in the United States and Canada. It's indeed a transboundary park because species don't really recognize borders. And then, starting from 1993, other areas were gradually protected in various regions. We have both a densification of the number of spaces, which allows for better distribution of areas within this large area, places where it is protected, and what has been systematically developed are the creation of corridors, which in English are called corridors, that allow spaces to be connected. This means that we need to imagine not only the fragmented areas, as shown in the previous slide, but also how we create bridges to ensure that animals can pass either over or under and ensure the continuity of populations, genetic continuity. And this is very important for species protection. I took another example, for instance, which is specifically the initiative to create corridors for the jaguar. We are also indeed in Latin America, so it starts from Mexico and goes all the way to Argentina, in dark green the current jaguar populations, which are arranged in different countries. In light green, the corridors that already exist, and in red, the corridors that are planned to ensure a complete genetic continuity between Argentina and Mexico to connect fragmented populations and restore a space that obviously overlaps with the functioning of human cultures and urban and rural life. It is indeed this juxtaposition of different spaces that ensures continuity. So what is being done on land with these corridors is also being explored at the marine level in various ways because, as you remember, there are patches in the high seas scattered all over. And in fact, for many species, it's somewhat the same. You have sharks, turtles, tuna, and many other pelagic species that travel between different places. The question arises of how we can ensure corridors at sea, which is more complicated. And so one of the initiatives proposed here that might be put in place is to define what they call mobile limit marine protected areas. That is to say, you have your areas specified in one place, but from the moment the populations, let's say of sharks or tuna that you want to protect, move, you can detect by remote sensing that they are moving, and at that moment, in real time, define that the MPA is moving and warn the fishermen in the area that they should not fish in certain places because they are putting them in danger. They may be fishing for sardines but end up catching sharks, which we want to avoid. So there is this idea of creating on land, which is relatively easy because we have strong reference points, but actually at sea we can also imagine in the near future having MPAs that move, as long as it is done in the interest of conserving fish and marine mammal populations. So we have started to gather some additional elements to see what needs to be protected and where, but there are increasingly more and more detailed models that are moving towards a more targeted and predictive approach of what needs to be done. Before looking at these models, I took one from the terrestrial and one from the marine environments. This is a little reminder for those who are familiar with it. Biodiversity is actually very, very different depending on where you are, and the level of species quantity in a given area varies considerably. Whether you are in the north or the south where there is almost no diversity. And then if you get closer to the equator, whether it's in the Andes, the Congo Basin or the Malay Peninsula, just to name a few examples, the redder it is, the more species there are. We can clearly see that the distribution varies differently depending on latitude, habitat type, and many other factors that come into play. And in precisely the identical way, but for different reasons, you have marine biodiversity will also be distributed very differently, with the highest concentration in the coral triangle. Beyond this region, species populations and diversity will vary depending on latitude, as well as whether they inhabit pelagic, open ocean or coastal areas. And all of this will indeed affect the type of protection or conservation we will implement from a terrestrial perspective. What I would like to show you now is an important initiative that was published in the prestigious journal Science called the Global Safety Net. As its name suggests, it is essentially about ensuring the safety and security net of our biosphere. That is, in other words, creating a protective and secure space that will ultimately maximize the potential gains. In this particular comprehensive and detailed study, they effectively and efficiently maximized both the protection of biodiversity and the capacity to sequester carbon in order to combat both the potential collapse of living organisms and the ongoing threat of climate change. What you have here in dark green, as you can see in this map, is what is already protected. In pink, what needs to be added for rare species, specifically those that are endemic species. In green, what needs to be added for ecosystems that are indeed very particularly interesting and extremely remarkable and noteworthy. In light green, what needs to be added because specific and unique things happen there. Rare phenomena occur. The rest is, in essence, a matter of intactedness, that is, the ability to ensure coherence and overall functionality and integrity of the whole. And then there are specific areas for climate stabilization. They even went as far as identifying the corridors that need to be protected. So it's a cartographic analysis work with various and intricate different layers. The whole represents a comprehensive and intricate global safety net that could both protect against biodiversity collapse and ensure effective and efficient carbon capture. This is crucial work done meticulously across diverse terrestrial ecosystems. On this particular slide, we observe a somewhat equivalent work but done with an additional third parameter. It involves conserving terrestrial biodiversity, sequestering carbon, and protecting water resources. What we have here is the mapping of priority areas. The redder they are, the more priority they have. The bluer they are, the less priority they have. In this model, it is an exact balance between biodiversity, carbon, and water. Compared to the previous slide, there are many similarities because tropical forests remain the richest, ensuring water and partially supporting carbon sequestration. However, there are still points of difference that I encourage you to look at closely by comparing closely. But what we see here is that if we take different parameters, we don't get exactly the same results. And so, as we can imagine, defining what will be protected from what will not be is also and especially a matter of political, national and international trade-offs. The type of representation, the type of model, and the number of parameters that will be taken into account will be very important. A similar work that was done on the oceans has allowed the identification of the most priority areas. Here, it is about identifying the areas that are most important for three key and critical parameters. But as in the vast, expansive and deep ocean, water matters less. As you can easily imagine, it is biodiversity, climate, because the ocean is very important for carbon capture, sequestration and storage as well. And food production, in fact, depending on the number of objectives to aim for, the marine protected areas that could be developed here would be very significant and extremely important. Between France and England, this area would be very important for the three factors and today is not subject to any specific protection. The same goes for the Italian coast, etc. So it is a way to inform public policies and to define which areas are priorities for conservation. We will find more interactions in the future with precise resolutions of remote sensing and location identification. This example is not directly related, but is showing a regional resolution. The objective in this exercise is to identify important areas for migratory bird species, particularly raptors, which tend to collide with wind turbine blades. This type of work allows the identification of bird corridors where wind turbines should be avoided, ensuring that wind turbine design and placement are minimally impactful for migratory birds. We are operating at both global and local levels, considering more factors to manage space and ensure that protected areas or human-occupied zones create minimal side effects. And then, to address the second part of the issue, which is the restoration process, we need to ensure that all aspects are considered and properly handled. Ecological restoration is about recreating, initiating, or accelerating the recovery of a disturbed ecosystem. And then why is it important? Obviously, because restoring very functional ecosystems is essential for stabilizing the climate and for the water cycle. As we saw earlier, it's essential to integrate these different parameters, to consider the different functions of an ecosystem and not just its biodiversity richness. The United Nations Convention to Combat Desertification recently published a report on ecosystem restoration, the Global Land Outlook, from which I have taken several points. To begin with, it highlights the importance of the restoration approach. The conditions of the land have tended to erode quite significantly in recent years. If we do nothing, there is no reason to believe it will get much better. We really need to try to restore as much land as possible to improve the situation. And restoration and protection will ensure functional recovery. So it is about healing the earth, restoring it, and once that is done, being able to take the appropriate measures, either to use it sustainably or to protect it. So that's really the other side. Indeed, there's conservation on one side, restoration on the other. And to give an example, for instance, still from the same report, or at least in a preparatory document for the report, if we take the specific particular case of a natural space in Africa, which is gradually cultivated, can lead to global collapse and significant soil erosion as its use intensifies. The abandoned land is on the right here. So the change in the Earth's overall intensity will go from one effect to another, from a wild state to a completely dysfunctional state. What I find interesting in this diagram is the representation here that says in a wild state there is a sort of natural balance of an ecosystem that functions well between the ecosystem's ability to sequester carbon, maintain soil fertility, regulate water, preserve biodiversity, and ensure the production of grasses, or in this case, crops. The more we intensively use a single parameter, such as crop production, the more we weaken other ecosystem services, eventually rendering the land sterile. There's no more water, it no longer sequesters carbon, it becomes very difficult for plants to re-establish themselves. So here we really have a process of desertification, for example, or indeed severe soil erosion. And so restoration is the process by which, either naturally occurring or assisted by humans, we gradually and steadily help ecosystems recover. To get a bit more familiar with this type of practice, I have taken a few illustrative examples. First, a visual example to start with. Here we are in India, and this is a trench that was clearly made by humans. On either side there isn't much. And then, if we gradually and carefully let the natural banks follow their course, we will have a mangrove ecosystem that will come back and eventually fully ensure the functioning of an integrated and sustainable ecosystem around the entire watercourse. I believe it is quite telling, and as you can clearly see, it happens quite quickly and naturally. So another example, this time taken from marine environments, is the fact, and this is indeed very good news, that it was published 2 years ago, that seagrass meadows, which are large submerged fields of algae, are very important because they are special places for fish to come and spawn and for the fry to develop. There was a concerning rate of decline in seagrass meadows in Europe in recent years. It's the seagrass beds that were increasing, the seagrass beds that were decreasing, and this is the average of the two. What we can see is that until the 70s there was a very drastic, very significant collapse, and from the 80s onwards, in both cases, whether it's the amount of seagrass beds decreasing, there are fewer and fewer, or the amount of seagrass beds increasing, there are more and more, and the difference between the two increases very significantly. The authors indicate that a key factor in the restoration of underwater seagrass meadows is the change in agricultural policies, with fewer inputs in modern agriculture in European countries, allowing previously threatened seagrass meadows to revive and flourish. On this slide, I will provide an example from the animal kingdom, as the previous two examples focused on plants. It can also indeed restore an ecosystem. It can also be an attempt to combat an invasive species. In Australia, a major issue is the feral cat populations. And the cats that have gone feral have the unfortunate tendency to eat all the small creatures they find, including various marsupials, lizards, arthropods, and other species. In Australia, over 100 species are threatened with extinction due to cat predation, leading to the formation of a special task force to capture and cull feral cats. It is worth noting that indeed we don't always think about it, but in small ecosystems, particularly on islands, species introduced by humans, starting with cats and rats, are very significant causes of species disappearance. Additionally, when these species are birds, they have often lost the habit of flying because they were not used to encountering predators. So, to take this time a much larger example, in size, although Australia is quite significant, the Great Green Wall, which is the significantly monumental and incredibly ambitious project that aims to restore hundreds of millions of hectares between Senegal and Djibouti. So it's a coalition of African countries that have implemented a detailed cooperation policy. The principle is to embark on an extensive reforestation program in any case, to plant and replant various types of trees to try to prevent the sand from spreading and desertification from expanding. They aim to pair it with crops to ensure the subsistence of indigenous populations. It's an extremely large project. It's probably the biggest coordinated restoration project in the world. The World Bank has technically considered the project successful, which is very interesting because it is always a challenge to know if projects of this size and scale can endure over time. Planting trees is one thing, but seeing the trees grow is another. Beyond announcements of millions of trees planted, this project has shown over several decades that it could potentially succeed, and they are now scaling up. The future will determine if restoration at this scale is possible, but it is probably indeed the most interesting example to follow today to see how to ensure very large-scale restorations. Restoration, as you have seen, is a word that means many things and can be interpreted in various ways depending on the context. In this small image from the Society for Ecological Restoration, I think it illustrates well the fact that it will reduce social impacts. We can try to restrict a pollutant or eliminate a pollutant, remove an invasive species up to achieving a completely restored ecosystem. And then all the steps in between, like reducing, improving, repairing, initiating, doing different things, and then ensuring complete restoration. There is a whole range of diverse practices for both terrestrial and marine ecosystems. It has certainly become a viable business and an important sector. In this 2015 paper, the size of the ecological restoration sector, it was between automobile production and steel production in the United States. So it is still a significant sector. Here, this is the number of direct jobs, 126,000 direct jobs. There are also indirect jobs. It's a sector that generates, I believe, 10 billion in revenue, at least in 2015 in the United States. The restoration industry operates in many countries worldwide. And so this might also be a way to ensure, if we want to talk about green jobs, I think this qualifies well, since we are technically in the process of repairing the biosphere. Just a small slide to visualize what this means in the United States, which is indeed probably one of the most advanced countries in this regard. Restoration projects are essentially concentrated around bodies of water and rivers. This is where there is shade. Here you can see it on the map. What is purple represents all the rivers and marshes, bodies of water. In light blue, these are the various catchment areas in this area, as you can see. Particularly for city supply, which is essential, for example, in many cases, such as a famous example in New York. The areas targeted to protect specific species are in green. There are also nearly 80 projects, but they are less important than the other two. And then, when we consider the forest and the role it plays in carbon sequestration, we see that this sector is almost the smallest. Out of a total of approximately 2,300 different projects, there are around 80 initiatives focused on carbon. There is a strong likelihood that this particular sector will grow, simply because with the current failure to curb the rise in carbon emissions, there is an increasing interest in so-called natural methods to capture it. And the fact is that the amount of carbon that can be stored by forests is undoubtedly very significant. So this is a paper that indicated if we could reforest all the areas where there is potential forest cover, we could capture around 205 gigatons of carbon. On 5 gigatons, that's enormous because, for the record, humanity emits around 60 gigatons each year. So here, 205 would be more than 3 years of annual production, all equivalent greenhouse gas emissions, not just carbon dioxide. But this paper is contested, and another paper published soon after suggests it was likely much less, about 5 times less, closer to 40 gigatons, which is under a year's worth. Nevertheless, it remains a very significant potential, and it is highly likely that in the coming years, the question of where we can restore, not just create monocultures, but restore functional ecosystems and measure the corresponding carbon, will indeed play a role not just for the ecosystem itself, but also for carbon sequestration. And from this point of view, one of the most important places to protect and restore is the mangroves, because mangroves have a significantly considerable capacity for carbon storage. This is a fairly recent and comprehensive paper by Duarte, which explores what current scientific understanding says about blue carbon. Blue carbon is the carbon that can be stored in various water bodies. We will have another example in food that we do not quite expect. And here, what we can see is that depending on the different ecosystems, the capacity to store carbon per hectare can vary from 500 for seagrasses to more than 1,500 tons of carbon for mangroves, which is very significant because tropical forests typically range between 200 and 600. That means we have a storage capacity that is 2 to 3 times higher. Additionally, since it grows faster, its capture potential is 30 to 50 times faster than forests. There is substantial work to be done in marine ecosystems. not only to restore ecosystems that are very important, as we mentioned earlier, but also because we kill two birds with one stone and allow for carbon sequestration. This is an illustration of the global safety net that we saw earlier. So various institutions have really taken up the pressing issue, and the Bone Challenge, for example, is a comprehensive United Nations initiative that includes several significant and impactful waves. The initial objective was to reforest approximately 150 million hectares of degraded forests or areas in total until 2020. And it turns out that the states have increased the number of millions of hectares they wanted to restore, which means they have revised their figures upwards, and now instead of 150 million in 2020, they have moved to 350 million by 2030. And so there are already more than 210 million hectares that are committed. So it's a process that works very well. The United Nations has declared the coming decade, from 2021 to 2030, the decade on ecosystem restoration, to really push countries to commit. On paper, this is something that is starting to take hold. So here, what I'm showing you, as you can see, this comes from the report on ecosystem degradation and restoration, is that if we take the 200 million hectares from the Bond Challenge and then 3 other initiatives, I won't go into detail, but which are also ways for states to commit to restoring ecosystems. On all the hectares where there is a commitment today, we are currently around approximately 1 billion hectares. 1 billion hectares in total, okay? So it's absolutely gigantic. So there is 1 billion hectares covering agricultural lands, forests, and pastures. While the Bond Challenge is solely about trees, other initiatives vary in focus. Using the different tools, we get something significant. 1 billion hectares, as it's not easy to visualize what that means, is the size of China plus the size of the United States. Here it is. This is the area in the world today that, according to governments, is being restored or for which they have shown interest in restoring by 2030.
So we are looking at numbers from the beginning.
So it is not absurd, if humanity puts in the necessary and consistent effort, that we can get back on a positive and sustainable trajectory that allows for the maintenance and preservation of essential ecosystem functions and a large part of the world's rich biodiversity. It is Sub-Saharan Africa that has been the most committed to this effort, because they are well positioned to see how much land degradation is a real scourge, followed by South America and Central America, Asia overall from south to southeast, and then Japan, Korea, Oceania. In Europe or North America, it remains quite minimal, generally speaking, in these regions. So 2 small spotlights on the 2 biggest places, specifically the most important areas of interest. Latin America, indeed, it's almost all the countries that are in reality playing the game and offering millions of hectares. So here, it's a particular initiative, 20 for 20, meaning 20 million hectares by 2020. It happened. And then Africa, AFR 100, African Forest Landscape Restoration Initiative, restore 100 million hectares by 2030. So each time we have initiatives from a certain number of countries that decide to either pool their resources and efforts or share their expertise and knowledge to try to make progress. I will finish this section on restoration with 2 additional brief points. The first is that the Society for Ecological Restoration creates an Ecological Restoration Week every year, which is an opportunity for thousands of projects to come to life. For the places where they do it, it's an opportunity to celebrate a sort of restoration festival, which helps engage young people in particular to explain why it's important and what they can do. It's an initiative that I find really interesting because it also ties the subject to education. And then, beyond restoration, well, let's say there are at least 1,000 possible restoration techniques, and there is one that is currently developing in Europe and gaining significant traction, which is rewilding Who is to have a slightly different vision of restoration. There are many ways for restoration. There is one where we can be very active, for example, including depolluting soils, etc. It can be very intensive in terms of machine and human time. And then there is another approach which says we just need to remove human pressure and it will grow back on its own. And so this is the one being developed here in rewilding. Again, in a few years, we will have a better idea of which methods are the most suitable in each context. There is already literature on this, but I won't go into detail. To conclude this section, the potential for restoration is immense. As the United Nations Commission on Desertification reports that between 20 and 40% of the planet's land is degraded, an undoubtedly enormous figure. These degraded lands directly affect more than half of the world's population. They cover cultivated lands, arid zones, wetlands, forests and grasslands around the world. There are degraded lands absolutely everywhere. As we have seen, this is a sector that can be very important. This is especially true in the United States, so why not develop it in other countries? And the international community has committed to restoring 1 billion hectares of degraded land by 2030, which is roughly the scale, the order of magnitude that scientists whom I introduced at the beginning of the episode were asking for. So to conclude on a topic still at the global politics level today, even though we have seen that there are a number of initiatives underway. Today, the states are unable to agree on how to establish a common policy in any way whatsoever. They had a first series, the Aichi targets, similar to the Kyoto Protocol for carbon. From 2010 to 2020, they were supposed to achieve 20 targets. He had to reach 20 targets, he had to reach 20 targets, he had to reach 20 targets, which are here with sub-targets, etc. All right, I won't go into too much detail. The only ones that were... So it's very easy to read as a graph. The sub-goals that have been successfully achieved are in blue. So there is indeed one. Those that were missed by not much are in green. There are 4 in total. I'll let you guess the rest. The Aichi targets were a complete and utter failure. And that's why I presented this earlier, because otherwise it would be very demoralizing. Many things are occurring on the ground, and it seems that something is indeed unfolding over the past few years. So the next steps will be really important. In 2020, there was supposed to be a conference, somewhat like the Paris Agreements, which was meant to determine the level of commitment from the states, the money that would be spent, the targets to be achieved, how many % we should reach on the seas, on the lands, etc. And this agreement did not take place because of COVID. Now, we are in 2022, and it has been postponed again. It is supposed to take place in October. Kunming is in China. China is not the most proactive country on these issues. So there are still uncertainties about the quality of the agreement that will be reached in October 2022. And that can be decisive. Now, I think we should also avoid overinterpreting what might potentially happen as an agreement. Just like the Paris Agreement of 2015 was an important victory, at the same time it doesn't guarantee that we can achieve decarbonization. It really is the commitment of everyone, countries, industries and citizens. For the restoration of the biosphere, it's somewhat the same issue. An international agreement will certainly help, but a lot of things are already happening. And so to conclude on this, the most important things we need to do collectively are to protect species, especially those that are critically endangered, protect the corresponding spaces, particularly to combat fragmentation, restore habitats, and we have seen that this can be done at almost all scales and in all types of biotopes or ecosystems. Massively reduce pollution, because it is one of the most crucial and extremely important inputs. We will only be able to maintain this if we manage to stabilize the climate in the long run, because even if it is not the most important factor today, the more time passes, the higher the degree rises, and the more it will become so. And it is indeed a matter of knowledge. It is a matter of education, because it is a subject that is far too unknown and on which the complexity of the problems and the type of solutions we can provide are not sufficiently taught, understood, and applied today.
Thank